13, we're going to be moving out of working with polynomials and talking a bit about radicals. We're going to define those terms at the very start of the lesson, but I just wanted to take a minute and tell you guys that I know Unit 1 feels very disjointed, like we're doing unit analysis, and then we move into polynomials, and now we're going to talk about radicals. But what Unit 1 is really trying to do is build a foundation and give you some kind of background knowledge that you may not have come across so far in your math classes that are really vital for being able to fluently work in Algebra 1. So as we start getting into some of the more advanced algebra topics, these are kind of the baseline pieces of information you need in order to understand some of the other things that are coming up. So I hope you can bear with us and get through this one last kind of topic that's going to show up in these last few lessons. I'll see you guys in a minute. Alright guys, this is lesson 13. We're going to be talking about simplifying radicals. As I said in the intro video, it is a bit of a jump from talking about our polynomials, but I think you're going to see some similarities as we start working with radicals more and more between those radicals and the polynomials. Before we get into the actual lesson, we have a bit of glossary work to do. So remember that at the very front of your packet, you have a glossary where you should be writing your vocabulary words. So the two words we have to define today are radical and radicand, and I've had several people ask me about these, so we're going to talk about them now. I wrote down, I lied, I didn't write down. I copied these definitions straight from the Georgia State Study Guide for our class. So rather than type them with all the symbols and stuff, I thought I'd just copy it and let you see it. So a radical is basically this symbol right here. Now, this definition sounds really complicated, but I'm going to break it down for you. It says the symbol, like that, is read the bth root of A and is called the radical. All that means, guys, it sounds crazy, but it's not, I promise. All that means is that when you see this symbol, it's called the radical. The one we are going to deal with in our class is specifically the square root, which means we are taking, when it says bth root of A, we're always going to be taking the second root. And A is just whatever number shows up underneath. So we'll say the square root of 16 or the square root of x or whatever number happens to be under there. So you're not going to have to worry about this crazy verbiage here. Now, for radicand, that is simply the math word for the number underneath your root symbol. So in this bth root of A, the A is the radicand. So I'm going to be referring to that radicand quite a bit as we go through today's notes. It's just the number underneath the root symbol. It's the number you're trying to take the square root of, okay? All right, so let's get into it. In this lesson, we're going to be simplifying radicals, so your learning target is simply that you can simplify those radicals. We have a very, very small amount of notes for this. We say that a square root radical is simplified, or in its simplest form, when the radicand has no square factors. And I know that's a lot of math in one sentence, but I'm going to show you what that means when we work some examples. The radical is also in simplest form when the radicand is not a fraction. So make sure you don't have a fraction under that square root symbol, which I don't think we give you too many problems like that. So go ahead and pause the video, get those words written down, and then let's go ahead and move into an example, because it's really going to be easiest to see what I'm talking about when we work out our example. Don't forget to put any questions over here in your question area. All right, so we kind of broke this down into several steps, and the example we're going to be doing is square root of 18. So the first thing you're going to do is you're going to complete a factor tree for the radicand. Now, it's probably been a long time since you've done a factor tree, but all a factor tree is it's where you take a number, in this case we're going to be pulling this radicand, and you break it down into its prime factorization. So you look at this number and say, okay, what are two numbers that I can multiply to get me 18? There are several different options. The first thing I think of is 2 and 9. If you think of 6 and 3, that's fine too. But I can break 18 down to 2 times 9. Whatever you've got here should multiply to give you your original number. Now, with a factor tree, you have to keep going until you get all prime numbers, meaning all numbers that can't be broken down into any new factors or any new multiplication problem. So 2 is a prime number. So I'm just going to carry 2 down because that one's done. This branch of my tree, though, 9 is not a prime number because 9 is equal to 3 times 3. So that's my factor tree. Step 1 complete. I don't know why I didn't give you more space, but that's step 1. Okay, and notice that 2 times 3 times 3 does equal 18. 2 times 3 is 6. 6 times 3 is 18. All right, step 2, we're going to look at our prime factorization and identify any pairs of numbers. Let me find my highlighter here. We want to see if we can find any pairs of numbers, meaning the exact same number showing up multiple times. What that tells us is that we have a square factor. So in this case, I have a pair of 3s. They don't have to be right next to each other. If I had a 3 over here and a 3 over here, that's still a square factor. That's still a pair of numbers. So underneath that radical, for step 3, I am going to be separating all the numbers under the radical into square factors and non-square factors. So here's what I mean by that. Right now, I have taken this radical and I'm rewriting it like this. The square root of 18 is the same thing as the square root of 2 times the square root of 3 times the square root of 3. Now we have a rule, which I've written here, that says if you've got a square root that's made up of two numbers being multiplied together, you can split that up into separate radicals. So what I'm going to do here is I'm going to look at this as the square root of 2 times those pairs right there. So the square root of 2, there's my pair that signifies that square factor. So what I'm going to do now is I'm going to write it as the square root of 2 times, except I'm gonna actually do this backwards or another way. I'm going to write it this way. The square root of 3 times the square root of 3. I'm going to put my pairs together, and then I'm going to multiply that times my singleton here, my square root of 2. Now, what I have here is the square root of 9 times the square root of 2. The square root of 9 is where some magic's going to happen, because now I'm going to pull my perfect squares out, and what I mean by that is the square root of 9 is equal to 3. Anytime you have a perfect square number, meaning a number that results from multiplying something by itself, that can be made into just a whole number. You can take the square root of this 9 and it's going to equal 3. It's not a coincidence that it equals the number that it's made up of here. If you've got 3 times 3, then the square root of that is just a single 3. So I'm pulling those perfect squares out and I'm going to multiply them by the remaining radical. So my remaining radical is 2. Now this is essentially a coefficient of this square root. Okay, and if you put in square root of 9 in your calculator, it's going to tell you that it's exactly 3. If you put square root of 2 in your calculator, it's going to give you some crazy decimal, some 1 point bunch of decimals that go on forever. So we want to leave that in this more simplified version of square root of 2. This is now the coefficient, which I already said. Sorry. All right, and that's it. That's all there is to simplifying these. Okay, I'm going to work through another slightly more complicated example just because I know this is a really different and complicated process, but I'm going to do it on another page where I have more space. All right, so the first thing I'm going to do is I'm going to look under this radicand and I'm going to split it up into its prime factorization. Now, when you have a mixture of numbers and variables, what I like to do is the first part of my prime factorization, I'm just going to split it into two spaces. So now I can say 100 times 100 is equal to what? Well, you could say 2 times 50, you could say 4 times 25. I'm going to say 10 times 10 because I like it that way. Now the next step is I'm going to continue on and finish up this side of my factor tree, and then I'll come over and deal with this variable and show you how to do it. So my 10s, 10 is equal to 2 times 5. So I'm going to have 2 times 5. And this 10 also equal to 2 times 5. If you use numbers other than 10 times 10 here, like 4 times 25, you should still end up with 2 2s and 2 5s. They may be in a different order, but that's okay. All right, so let's go ahead and come over here and finish this one up. X cubed is made up of x times x, and I'm just going to put myself a third little line here, times x. That is 3 x's. Now, that's step one. Now the next thing I need to do is go through and find all of my pairs. I have a pair of 2s. I have a pair of 5s. I also have a pair of x's, and that's important to note. The only thing that's left without a friend here is this last little x. So that's going to be my one little singleton guy that's going to hang out. So the next step is to rearrange these so that my pairs are together and I have a series of radicals. So I've got 2 times 2, that's one radical. I've got, that's being multiplied by my 5 times 5, there's another perfect pair. And then I've got my x times x. And then the last one is that single little x that didn't have anything to pair up with. Right? So now I'm going to go through the square root of 2 times 2 is just going to be 2. Remember that there's a multiplication in between all of these. So the square root of 5 times 5, or the square root of 25, is just 5. And I'm going to multiply that times the square root of x times x. Remember that's x squared, and the square root of x squared is just x. The one piece that's left is this radical. That guy can't come out of the radical because he doesn't have a pair. I do have one last little step here on this one, and that's to go ahead and multiply all these together. 2 times 5 is 10. 10 times x is just 10x. So I have 10x times the root of x. And that is my final answer. All right, I am going to do a separate little video. You have practice on page 23, but I'm going to do an additional help video that is going to show you a little shortcut. So once you've done some practice and you start noticing some patterns, there are ways to shorten this process a little bit. So I'm going to show you another way to do it that serves as a shortcut. Only watch that video once you feel kind of comfortable with the process that I've shown you. It will be available on the website just right underneath this video.